Did you know that China has just created the thinnest battery in the world? You could even call it a sheep battery or a leaf battery. And do you know how electricity is stored inside a battery? If you understand the principle behind it, you can make one yourself too. In today's video, I'm going to show you how to create a battery of your own design. Don't forget to hit that like button, subscribe, and turn on the notification bell so you won't miss any of my future DIY experiments. I'm going to use these 3 dead batteries to create a brand new one. When batteries end up in landfills, harmful chemicals like lead, mercury, and cadmium can leak into the soil and water, polluting the environment and posing risks to human health and wildlife. Proper recycling and creative reuse are essential to reducing their impact. If you got batteries like these at home, don't throw them away just yet. They can be really useful. Let's jump right in and start turning them into a brand new battery. Besides these batteries, I'll also prepare the copper tube. This will be an essential part of our setup, serving as the outer casing for the new battery. First, I'm going to take apart all these batteries to extract the black powder inside. This material will be an important component for making our new battery work. You can see the internal structure of a battery here. It shows the layers of materials, including the black powder, the metal casing, and other components that work together to store and release electricity. That black powder is the active material inside the battery, usually made of manganese dioxide mixed with carbon. It's responsible for the chemical reactions that generate electricity when the battery is in use. Be sure to wear gloves and a mask while handling the battery materials. The powders and chemicals inside can be harmful if they come into contact with your skin or are inhaled, so safety first. I'll use a pair of pliers to separate the outer casing and then peel it off carefully. I'll scoop out all of this black powder and put it into a plastic cup. Using a plastic container is safer to avoid any unwanted reactions with metal surfaces. I'll repeat the same process with the remaining batteries. Carefully extracting the black powder from each one and adding it to the plastic cup until I have enough for our new battery. Next, we'll add sand. I'll add a few spoonfuls of sand into the cup. This will mix with the black powder and help create a consistent, stable material for our battery. The sand in this mixture acts as a filler and stabilizer. It helps keep the black powder from clumping too much, ensures even distribution. And provide structural support inside the battery so the materials stay in place and the battery works more reliably. After mixing everything thoroughly, I'll go back to the copper tube. This is where we'll start assembling the battery, using the tube as the casing to hold all our materials together. Now, I'll clean the outside of the copper tube. I'll use some WD-40 to help clean it. Spraying a bit on the surface makes it easier to wipe off any grime or rust, leaving the copper tube shiny and ready for use. The copper tube should have a diameter just about the same as the battery and a length of around 10 to 12 centimeters. This size will make it fit perfectly and provide enough surface area for our battery to work effectively. After cleaning with WD-40, the copper tube looks much brighter and shinier. Its surface is smooth, with the natural reddish gold color of copper clearly visible. Next, I'll take a plastic cap. This will be used to close one end of the copper tube. Keeping the battery materials securely inside, I'll drill a hole in the plastic cap. This will allow the metal rod to pass through and make contact with the materials inside the battery. I'll secure everything in place using hot glue. I'll place the copper tube into position and pour in the hot glue. This will fill any gaps. Hold the tube firmly in place and ensure that the battery components stay securely inside the casing. Next, I need a metal rod or wire, and I'll use this one. It can be made of copper, iron, steel. Any conductive metal will work for this part of the battery. It's a bit bent, so now I'll straighten it out. This ensures it fits properly inside the battery and makes good contact with the other materials. Next, I'll insert the metal rod into the hole. It will go through the cap and sit inside the copper tube, connecting with the battery mixture to help conduct electricity. Once the battery casing is ready, I'll move on to preparing the materials for the inside. This is where we'll combine the black powder, sand, and any other components to create the active mixture that will generate electricity. I'll prepare a cup of water. Then, I'll add some table salt into the water. The salt helps increase the conductivity of the solution, which is important for the battery to work effectively. After preparing all the materials, I'll now put them inside the copper tube. This includes a black powder, sand, and the saltwater solution, carefully layering and packing them so the battery mixture is evenly distributed. I'll add the sand and black powder mixture first. This forms the main active layer inside the battery, providing material that will generate electricity. I'll make sure it's evenly distributed and gently packed down. Next, I'll pour in the saltwater solution. I'll use a syringe to carefully inject the saltwater solution into the tube. This allows precise control, letting the liquid soak the mixture evenly without spilling or making a mess. This will soak the sand and black powder mixture, enhancing conductivity and allowing the battery to start generating electricity. Once all the materials are inside, I'll use some clay to seal the open end of the tube. Pressing the clay firmly creates a tight closure, keeping everything in place and preventing the mixture or liquid from leaking out. I'll apply hot glue over the clay to secure the end firmly. This adds an extra layer of protection, keeping the seal tight and ensuring that the battery material stays safely inside. Now, I'll measure the voltage of the battery. Using a multimeter, I can check how much electricity it's generating and see if our homemade battery is working properly. The voltage is showing up on the meter, but it's still not very high. Next, I'll identify which end is a negative terminal and which is a positive terminal. So we know how to connect it properly in a circuit. The red wire will be the positive terminal and the black wire will be the negative terminal. As you can see, the copper tube serves as a positive terminal and the other end is the negative terminal. Now, I'll attach wires to the battery terminals. I'll connect the red wire to the copper tube, positive, and the black wire to the opposite end, negative. Making sure the connections are secure will allow the battery to deliver power reliably when used in a circuit. On the body of the battery, I'll solder the wire in place. This ensures a solid, stable connection to the copper tube so that the positive terminal can reliably conduct electricity. Before soldering, I'll use coarse sandpaper to scratch a section of the copper tube. This removes any oxidation and creates a clean, rough surface, which helps the solder adhere better and ensures a strong electrical connection. Next, I'll connect it to a charging cable to recharge a battery. This allows the homemade battery to regain energy and be ready for use in powering small devices. After 30 minutes of charging, the battery has absorbed some energy, and we can check its voltage again to see how much it has increased. At this point, the voltage reads 1.4 volts, but the battery isn't fully charged yet. We'll need to continue charging it until it reaches its maximum capacity. Now, I'll connect the homemade battery to an alarm clock. You can see the hands of the clock moving smoothly. This proves that even a simple homemade battery can generate enough electricity to operate real electronic devices, demonstrating the effectiveness of our DIY project. To make connecting to the power source easier, I'll attach the charging cable to alligator clips. This allows a secure and convenient connection to the battery terminals while charging. To make connecting to the power source easier, I'll attach the charging cable to alligator clips. This allows a secure and convenient connection to battery terminals while charging. Now, I'll charge it for another 30 minutes. This will help the battery reach a higher voltage and store more energy for longer use. After another 30 minutes of charging, the battery should have stored more energy, and we can check its voltage to see how much it has increased. The voltage now reads 1.6 volts, showing that the battery has gained more charge, though it may still need additional charging to reach full capacity. In conclusion, we've successfully transformed old, dead batteries into a functional homemade battery. By carefully extracting the materials, preparing the copper casing, and assembling everything with proper safety precautions, we were able to generate enough electricity to power small devices like an alarm clock, Hey, have you ever been fascinated by the idea of restoring old batteries? Don't hold back that passion anymore. Welcome to today's awesome video, where I'll guide you into this world, simple, fun, and incredibly creative. With just a few easy-to-find materials, you'll be able to bring batteries back to life and create your own source of power. Are you excited yet? Sit back, hit play, and let's dive into this exciting battery restoring journey together. Don't forget to like, subscribe, and share your passion in the comments. Take a look at some everyday items that often stop working once their batteries die. That old alarm clock on your bedside table, with its faded buttons and sleeping hand, no longer rings to wake you up. A wireless mouse that once glided smoothly across your desk now sits idle, its light no longer glowing. Or even a camera remote control covered with a thin layer of dust that refuses to respond no matter how many times you press the buttons. These small devices may seem lifeless, but the truth is they're just waiting for their power to be restored. Alright, now let's check the voltage of these batteries to see if there's any power left inside. This step is super important because it tells us whether the battery is really dead or if something else might be causing the problem. Before testing the old batteries, I'll first measure a brand new one to make sure the multimeter is working properly. As you can see, the reading shows the correct voltage for a fresh battery. This confirms that the tester is accurate. Now, let's test this Duracell 1.5 volt battery. Ideally, it should show around 1.5 volts if it's still good. But as you can see, the multimeter displays 0 volts. That means this battery is completely drained and no longer provides any power. Next, let's move on to this 3.7 volt battery. Normally, a healthy one should read close to 3.7 volts on the multimeter, but here, it's also showing 0 volts. Normally, this button cell battery should still show some voltage if it has any life left, but as you can see, the multimeter reads 0 volts again. That means this remote is completely powerless too. So, we confirm that all of these batteries are completely drained. But here's the exciting part. This doesn't mean they're useless yet. Instead of throwing them away, we're going to try bringing them back to life. In this next step, I'll show you how to safely prepare the batteries for restoration, and then we'll begin the process to recharge and revive them. Get ready. This is where the fun really begins. First, we'll need a small piece of plastic tubing. Measure out a 10 centimeter section of the plastic tube and make a clear mark at that length. This will ensure we cut the tube to the right size, making it easy to handle and perfect for holding the battery securely. Next, use a small saw to cut along the mark on the plastic tube. Saw slowly and steadily to keep the cut straight and clean. Once done, you'll have a neat 10 centimeter piece of tubing ready for the next step. After cutting, use a heat gun to carefully warm up the edges of the plastic tube. As the plastic softens, gently shape it to fit the battery more securely. Be sure to move the heat gun back and forth to avoid overheating any one spot, and let the tube cool down so it holds its new form. Trim off any excess plastic from the smaller tube so it fits neatly around the holder. This will make the setup cleaner, easier to handle, and ensure the battery sits securely in place. Don't throw away the leftover plastic pieces. Instead, we can repurpose them as end caps of the tube. Cut them into small, flat sections and place one on each end of the holder. These caps will close off the tube neatly and help keep the battery more secure inside. Now, use a small amount of super glue to attach the plastic caps firmly to both ends of the tube. Hold them in place for a few seconds until the glue sets. This will make the holder sturdy and ensure the battery stays well protected inside. After the caps are securely glued in place, mark 2 small points, one at the center of each end cap. These marks will guide us where to create holes later. Next, use a small drill to carefully make holes at the marked points on both end caps. Drill slowly to avoid cracking plastic, and make sure the holes are just wide enough for the battery connectors to pass through. Take 2 small bolts and insert them through the holes at each end of the tube. Secure them tightly in place with matching nuts on the inside. These will serve as strong connectors for the battery terminals, making it easy to attach wires later. Keep them slightly loose so they can be adjusted later to fit the exact size of the battery. For the wires, you can even repurpose an old phone charging cable. Simply cut off the connector and strip away the outer insulation to reveal the inner wires. Carefully strip off about 1 to 2 centimeters of the insulation at the end of each wire to expose the copper strands inside. Twist the copper wires tightly so they stay together and are easier to connect securely to the bolts. Next, attach the exposed copper ends of the wires to 2 alligator clips. Insert the wire into the small hole at the base of the clip, then tighten it in place or use a bit of solder if needed. These alligator clips will make it easy to connect and disconnect the battery during the restoration process. After finishing the wiring and attaching the alligator clips, it's time to prepare for testing. Place the battery into the holder and gently adjust the bolts so they make contact with the battery terminals. To fit the battery properly, gently adjust the bolts on each end of the tube. Slide them inward until they touch the battery's terminals, but don't over-tighten, just enough to hold the battery firmly in place. This way, the holder can adapt to different battery sizes while still ensuring good electrical contact. Next, connect the alligator clips to the power supply. Red to the positive, plus symbol, terminal, and black to the negative, terminal. Double check the polarity before turning it on to make sure the battery is charged safely. For the power source, you can simply use a standard 5-volt phone charger. This provides a safe and steady voltage to start bringing the 3.7-volt battery back to life. Let the battery charge until you feel it becoming slightly warm to the touch. This warmth is a sign that current is flowing inside and the battery is starting to recover. At this point, stop charging to avoid overheating and damaging the cell. Now, disconnect the charger and use the multimeter to check the battery's voltage again. The multimeter now shows a reading close to 3.7 volts. That means the battery is taken in power and is back to a usable state. Compared to the 0 volts we saw earlier, this is a big improvement and a clear sign that the restoration worked. Next, let's try charging the Duracell 1.5 volt battery. Connect it to the holder the same way as before, making sure the positive and negative terminals line up correctly. Then attach the alligator clips and connect them to the 5-volt charger. Allow the battery to take in some current for a short time, but be careful. Alkaline batteries like this are not designed to be recharged, so we only charge briefly to see if it can regain some power. After a short charging period, disconnect the charger and measure the Duracell battery with the multimeter. Place the red probe on the positive end and the black probe on the negative end. This time, the reading shows closer to 1.5 volts. Finally, let's move on to the small button cell battery from the camera remote. Place it carefully into the holder and connect the alligator clips. After giving the button cell a short charge, disconnect it from the power source and check it with the multimeter. The reading now shows close to its original rated voltage, which means the tiny cell has successfully regained some energy and can power the remote again. Test the button cell with a small clock. Insert the battery into the back compartment and set it in place. Almost immediately, the hands of the clock begin to move again, proving that the restored battery has enough power to bring the clock back to life. Test the restored battery with a wireless computer mouse. Insert the battery into the compartment and switch it on. Right away, the LED light on the mouse turns on and it starts moving the cursor smoothly on the screen, showing that the revived battery is working perfectly. Now, place the button cell back into the camera remote and close the cover. Press a few buttons to test it, and you can see the remote is working again. This proves that even a small button cell, once thought to be completely dead, can still be brought back to life with a simple restoration process. In the end, we successfully revived different types of dead batteries and proved they can still power up everyday devices. It's a simple way to save money and reduce waste. Don't forget to like, subscribe, and share your thoughts in the comments.